The first thing I want to talk about is primality test. Primality test is some tests that answer the question for any arbitrary integer n, is it prime or composite? There are some algorithms for check this condition. For example, trial division, when we check all divisors of the number n, but the main disadvantage of this method was slow time for big value of n, integer n. The second one was firmer primality tests, which have better complexity time for, but it have disadvantages such as Carmichael numbers, which are composite numbers, but Fermat test gave us answer is that it is a prime. The third one, and in which we focused, is Miller-Rabin primality tests, which have the same complexity time as Fermat test, but didn't have some problem as Carmichael numbers. The Miller-Rabin tests, the main condition was these two. So we choose some arbitrary base A, check two conditions. If one condition of these two is met, is correct, then n is probably prime. If all conditions are false, then n is composite. And Miller-Rabin tests work for some set of bases. So we choose some several bases and check all these conditions. If condition 1 or 2 met is correct, then we call A witness of primality of n. If all numbers, all bases are witness of primality, then we call the n is probably prime. But there are some problems, such as there exists composite n for which A is a witness of primality. So we must check the distribution to know how we can improve this algorithm. For this, we define a set of witness to primality of n, of number n, and there are some theorem for number of such numbers. For example, if n is prime, then number of this is equal to Euler function of n. If n is composite, then it's this inequality is correct for any n is composite. Also, for number of witness of primality, there exists a formula which we can use in if needed. But in this work, we compute the probability of choosing a witness of primality, which computes by this formula. And also, we compute the average probability on some set A, in which work we use set A is range from 1 to some upper bound x. In which work we focus on triple prime numbers, which multiplication of 3 different prime numbers, and we focus on 2 cases. The first one was general cases, all triple prime numbers from the range, and the second one is worst case, with some additional conditions which give us the largest value of numbers of witnesses. The general cases when we select all triple prime numbers from our range. We add some functions. For example, this function is sum of frequency of probability for any prime number with fixed number p and q, and the number of prime numbers on the interval, some interval. We gave theoretical estimation for sum and for number of the prime numbers, and we gave estimation for average frequency on interval from 1 to x. This one was upper bound, but if we check on experimental result, we see that ration of this function very slow, approximate to 1, and is less than 0.1, which means that it's upper bound, but very bad approximation and needs to improve. For example, this comparison the result of function. So this was theoretical, found by this formula, and this was practical, found by select all prime numbers. The second case was the first case, in which we add some condition. This condition gave us the infinity numbers, because this 3 was from Chinese reminder theorem, and this one was some prime numbers. P1 and Q1 is prime numbers, and D was an odd integer. For this case, we gave this estimation, which was beta, and have y0 is the least possible r, which met with this condition. And if we see the experimental result, so we saw that function ratio is approximate to 1 very fast, and we gave good result for approximation for only for this case. Which means that we found upper bound for all for both cases, for general cases and for worst cases, for these cases also, with additional condition. But for worst cases, it was very good. It has very good approximation, but for general cases, it needs some improvement to more better approximation. Better approximation. Thank you for listening.